Hi everyone, welcome back to chemistry. In this video, we're going to talk about solution concentrations, which is 9.4 in your textbook. There are lots of different ways to figure out the concentration of a solute in a solution and to express that value. But what we're going to focus on mostly in this class is something called molarity. And we talked a little bit about that in our lab last week, but I want to get more in depth in this video. But first, let's think about concentrations as a whole. So kind of more generally. So what is the concentration of a solution? Well, it's the amount of solute dissolved in the solution. So it's a measure of how much of your solute is in how much of your total solution you have. Okay, so if it was hydrochloric acid that we've diluted with water, well, we're often concerned because acid is corrosive. We want to know, well, how concentrated is that solution? How much hydrochloric acid is dissolved in my hydrochloric acid / water solution? So in chemistry, a lot of times we're working with moles of our solute, right? We just did a lot of stoichiometry last week, talking about, converting from moles of one thing to moles of another, or measuring how many grams of you have versus how many moles you have, and so on. So a lot of times we actually know how much of our solute we have in units of moles, like we have here. So molarity is a way to talk about concentration in terms of moles, specifically in terms of moles of solute per liters of solution. Okay, those are our units for molarity, is moles per liter, moles per liter. How many moles of my solute are in how many liters of my solution? So in a 1 molar solution of NaCl, we have 1 mole of NaCl per 1 liter of solution. Okay, so a lot of times we talk about our solvent being water, right? So your solution is a mixture of your solute plus your solvent. Whoops. Right, so in terms of salt water, you would have your NaCl would be your solute, water would be your solvent, and the solution that's created is your NaCl solution, or your salt water solution. Okay, so this is the total liters of all of that solution mixed together that you have. But we want to know, okay, how much of that solution is just NaCl, our solvent. Sorry, our solute. Woo! All right, so how do we actually do calculations involving molarity? Because it is actually an equation, right? This, oops, whoa, what happened? Hold on. This is an equation for molarity. Remember, molarity is expressed with a capital M. We talked about that in class. So that's molarity. Molarity is expressed with capital M. That's the variable we use for molarity. And then that equals moles of our solute per liters of solution. So we can think of this as an equation. So M equals moles solute over liters solution. All right, so let's go ahead and try this out. So what is the molarity? We're trying to find M, right, of a 0.500 liters of NaOH solution if it contains 6 grams of NaOH. All right, so we're given our volume in liters, so that's actually perfect. We already have that bottom number there, or our denominator there. We're looking for M, so we'll go ahead and make that blue. And then we don't quite know moles of our solute, but we do know grams of our solute, right? So we can get to moles. So let's do that first. So my first step is I want to get from grams solute to moles solute. So I can do that. So I'm given that I have 6.00 grams of NaOH, my solute, and I want to get to moles. So how am I going to get to moles from grams of NaOH? Yeah, we got to use the molar mass. Got to use the molar mass. Molar mass connects grams to moles. So kind of full circle here. So let's get my calculator out. All right, and let's just calculate the molar mass over here. So remember, we can use that molar mass as a train track in our dimensional analysis problem, or as a conversion factor. So let's say we want grams on the bottom because we want them to cancel out. So let's go 39.997 grams of NaOH in 1 mole of NaOH. Okay, and then we can cancel out our grams. Hopefully this is looking familiar. And we got 6.00 divided by 39.997. So that is 0.15, let's go 3 sig figs moles of NaOH. All right. So we got 0.150 moles of NaOH. So let's do our second step now. So now we actually have, this is our green number, the one that's going to go on top, right? So let's move this equation down here. So we're looking for M, the molarity, right? And we've got our moles of our solute over liters of solution. So let's do this. Start plugging in these values. So we've got moles of solute, which is 0.150 moles of NaOH. So I'm going to use the unrounded value, but I'm not going to write out that whole thing here. And then on the bottom, we have our number in yellow, which is our volume. So that's 0.500 liters of what? NaOH solution. Solution, solute plus solvent, okay? Total solution. So how much of our solute is in our solution total, expressed in moles per liter? All right, so 0.300 moles per liter is our molarity. So we can express that as 0.300 molar NaOH. That's how you would see it kind of in lab, NaOH. All right, so let's try out this learning check together. So this says zinc reacts with hydrochloric acid to produce hydrogen gas and zinc 2 chloride. So we want to know how many liters of a 1.50 molar HCl solution completely react with 5.32 grams of zinc. Whew, okay, so what is this actually asking? So in order to kind of figure out what this is asking, let's go ahead and color code a little bit. So we've got grams of zinc, and I'm going to put that in yellow because just following our molarity equation, which actually I'm going to write that up here, moles solute, liter solution. All right, so we've got, yellow is our amount of our solute. And then we know our molarity, which is 1.50 molar HCl. And then we want to know our volume, which we'll leave in green. Okay, so there's several steps to this. So let's go ahead and just kind of think things through. So we have grams of zinc. So I'm starting with grams of Zn. And I want to eventually end up in what? Yeah, liters of HCl. Liters of HCl, right? So if I want to get from grams of zinc to liters of HCl, the only way I'm going to be able to do that is to go through moles. Because in order to figure out how many grams of zinc react with how many liters of HCl, I need to use my balanced chemical equation, right? I need to use my mole to mole ratio. So I got to get to moles first because right now I'm in grams. So let's say, let's kind of add that step in here. So first I want to go from grams to zinc to moles of zinc. And then I want to go moles of zinc to what looks like, we want to know moles. We want to eventually end up in liters of HCl. So we got to get to moles of HCl first. Those are the two things we're comparing. So we got to get to moles of that other thing as well. And then I want to get to liters of HCl. Okay, so that's kind of my general problem-solving process, but how are we going to do that step by step? Quite a bit. Hopefully you guys can still see this okay. So let's go ahead and figure this out. So we're starting with grams of zinc, and how many grams we actually know. So we're starting with 5.32 grams of zinc. All right, so first I said I want to get to moles of zinc, right? I'm in this step here. I want to get to moles of zinc. So how do we get from grams of zinc to moles of zinc? Yeah, our molar mass. So I'm going to go ahead and calculate the molar mass on my own, and then I will meet you back here just to kind of save us a little bit of time. All right, so molar mass of zinc is actually just the atomic mass number on the periodic table because we only have one zinc atom. So 65.38 grams per mole of zinc. So we can go ahead and cancel out those grams of zinc, and we're left with moles of zinc. All right. We don't want moles of zinc, though. We want to keep going. So let's go ahead and continue on. So we want to get to moles of HCl next. All right, how are we going to get to moles of HCl? Using our balanced equation. Yeah, we know 1 mole of zinc reacts with 2 moles of HCl to give 1 mole of H2 and 1 mole of zinc 2 chloride. How did I know that? Yeah, our coefficients that are in front of our chemical equation, okay? All right, so 1 mole of zinc, 1 mole of zinc is going to go on the bottom. 2 moles of HCl, so 2 moles HCl. All right, so let's go ahead and cancel out those moles of zinc. All right, and now we're left with moles of HCl. Now it's kind of the new part. We've done all this before, right? This is all just our regular stoichiometry. But how do we get from moles of HCl to liters of HCl? Using our molarity. Yeah, molarity can be used as a conversion factor. Remember, molarity is just the amount of moles of solute you have over liters of your solution, moles per liter. So if I know the molarity of my HCl, let me go ahead. If I know the molarity of this thing here, HCl, which I do, right? 1.5 molar HCl. What is that saying to me? That's saying to me that I have 1.50 moles of HCl per 1 liter of HCl. Okay? All right, so let's go ahead and use that molarity. So we've got, as our conversion factor. So we've got 1 mole of, 1.50 moles of HCl per 1 liter of HCl solution. And let's get rid of this color here. And then we can cancel out those moles of HCl. And we're left with liters of HCl, which is what we wanted. Isn't that kind of cool? Phew. Okay, so lots of steps there. And I did it all in one step, but you could break it up if you wanted to. It's up to you. I just wanted to show you how to do it all in one step so that, you could do that in the future. So let's go ahead. Actually, I'll write what it equals down here just because we're getting kind of long here. So all right, so I've gone ahead and done the calculation for us just to save time, but let's go ahead and round to the right number of sig figs. So we started with 3 sig figs here, so we better end up with 3. So we'll have 0.108 liters of what? HCl solution. Yeah, because remember, we wanted to know how many liters of solution completely react with that many grams of zinc. All right, so let's just kind of summarize how we did this. So we had our, we had grams of zinc. Actually, let's color code. So we had grams of zinc, right? And we wanted to get to moles of zinc through the molar mass. And then we said, okay, we can use our mole to mole ratio or mole to mole factor to get from moles of zinc to moles of HCl, right? Moles of zinc to moles of HCl. And then we can use our molarity to get, because we were given our molarity of our HCl solution, so we can go from moles of HCl to volume of HCl using our molarity. So pretty cool. So you'll be practicing this in your lab. It doesn't need to be perfect. Just try your best. And then I think that's it for this video. There is this cool concept map at the end of chapter in your textbook, which is on page 333. So this is page 333 in your textbook. So if this helps you out, you might want to kind of look at it and maybe even write it in your notes or take a picture of it so you can look at it later while you're working on homework and stuff like that. All right, I'll see you in the next video.